At the moment, we're really struggling with the way that we make seasonal flu vaccines and eggs, because there's components of it, particularly this H3N2 component, when you grow these viruses, and that's how we make flu vaccine. We grow the virus, then we inactivate it, break it up, and use that as a vaccine. But what happens with some of these H3N2s, when it gets into eggs, it does change a little bit. And that means it's no longer quite as closely matched to the viruses out there in nature as we hoped. And so that is, I think, certainly helping to reinvigorate this whole discussion about, the vast majority of global supply of food, that flu vaccine relies on eggs, and we should get away from that, I think. Should we completely get rid of eggs? There's an argument to say no. It is it's a technology that's served us well for some 40 odd years. The manufacturing capacity is already in place, and that's also important. It's not just a matter of how good your vaccine, but you've got to have enough doses to actually vaccinate people. And so, if we have a trade-off between perhaps a better vaccine but less doses versus something that from year to year, some years is better than others but can produce the doses, I think that's another argument that we've got to have, another discussion at least. So, I think there probably will be a bit of a move, a reinvigorated discussion about moving away from eggs, but personally I find it hard to imagine that it's going to disappear, at least in the near future. If we look at what's available in terms of flu vaccine this year in the US, there's lots of different manufacturers, slightly different formulations, but there are really three major ways of making that vaccine. One is in the embryonated chicken eggs, and that's how our nasal spray and most of the vaccine we get in our arm is made. There is a product that is made in cell culture, so instead of growing the virus prior to making vaccine in eggs, this is grown in cultured cells. And there is a further product that's actually made, again, in cells, but doesn't actually use the virus at all. It just takes parts of the virus, the active ingredient, if you like, and produces that in cultured cells. One of the most exciting things that have come out in the last few years surrounding treatment options for flu is the development of a novel class of anti-influenza drug. So these work a little bit different from vaccine in that they can be used to actually treat an infection after you catch it, where a vaccine protects you from getting, or at least from getting it or getting severe disease. We've relied on essentially one class of flu antivirals for the past few years, and this is the neuraminidase inhibitor. Perhaps many of you have heard of Tamiflu. This new class of drug actually targets a completely different part of the virus than our existing drugs do. It's a product that's actually licensed in Japan, and one of the least selling features of that drug, it's a one tablet. So rather than some of the neuraminidase inhibitors, which have a 5-day course, this is a single tablet taken once. And so this is under review by the FDA for use in the US, and certainly there's hope to be some news on that front before the end of the year.